Hello everyone, it's Miss Thomas, and today we're going to look at graphing linear inequalities. So the steps for graphing linear inequalities include graphing the points on a line as you would a regular linear equation, determine if the line should be dashed or solid, and determine which side to shade to represent the solutions using a test point. So a linear inequality is just like a line. We might have y equals 2x. A linear inequality is just going to be something like y is greater than 2x. So if you think about the graphs of these two equations, or these two things, the y equals 2x is going to have a y-intercept of 0 and a slope of 2. So it's just going to increase like that. And so technically the solution to this equation is anything that falls on this line. Y greater than 2x same thing, it's just like a line. It's going to have a y-intercept of 0. It's going to have a slope of 2. But some of the differences are, because this is just a greater than sign and not a greater than or equal to, then my line is going to be dashed. So instead of connecting it with a straight solid line, it's going to be a dashed line. And then solutions to this are not just things that fall on that line, but things that fall to one side or the other. And so that's this idea of a test point. And so generally, the easiest test point to use is 0, 0, but 0, 0 is part of our line. We want to use a point not on the line. So I'm going to use the point 1, 1 as my test point. So I want to know, does that point 1, 1 fall into this solution set? So I'm going to plug in 1, 1 to the y greater than that. Y greater than 2 times 1. Y 1 greater than 2. So this is false. So that means that this point right here, the 1, 1, is not a solution. So the solutions have to fall on the other side of that dashed line. So the solutions are anything on the left side, the upper left side of this dashed yellow line. Let's look at some more examples. So we are asked to graph 2x minus 3y is less than or equal to 12. So I'm going to go ahead and I am going to put my axes on here. I'm going to go by ones to make it nice and easy. And then I'm going to graph this. Since I'm in standard form, I'm going to go ahead and graph using the intercepts because that's going to be the easiest way. So even though we have this inequality, to find the intercepts, I'm going to just pretend like we don't. So the x-intercept, I know that my y has to be 0, so I'm going to do 2x minus 3 times 0, and just find what it would be for the related equation. So it's going to end up being 2x equals 12, so my x-intercept is going to be a 6. 1, 2, 3, 4, 5, 6. That's 0.60. That's my x-intercept. Now to find my y-intercept, I'm going to switch it up. Instead of doing y equals 0, I will do x equals 0. So 2 times 0 minus 3y is equal to 12. So that's going to end up being a negative 3y is equal to 12. Dividing both sides by that negative 3 y will be equal to -4. Great. And then I want to go ahead and connect that. Since I do have the or equal to, then I can connect these with a solid line. So this is my boundary line for my inequality, but an inequality should always have shading. So I am going to use a test point, and because my line does not go through 0, 0, I'm going to use 0, 0 as my test point. So basically, do I shade above this line or below this line? And I will do this work up here. So you could use any coordinate, but we're using 0, 0 because it's easy, because then I can just go 2 times 0 plus 3 times 0. Is that less than or equal to 12? 0 is less than or equal to 12, so this is true, which means that 0 is part of the solution. So I want to shade everything above that line to show that anything in this region will satisfy the inequality that we have been given. So here's one for you to try. Graph y is less than or equal to 2x plus 4, and make sure you do all the shading and the dotted versus the dash.